Hello. So in this video, we're going to talk about the distributive property, in particular of multiplication over addition. So in part one, we're going to talk about what the distributive property is from a procedural standpoint. What are you doing? In part two, we'll explain a little bit of how to make sense of the simpler cases. And then part three, we will tackle the monster. All right, so part one, what is the distributive property? Well, I'm going to go ahead and write on the side here a thing called PEMDAS. We've already explored this in other videos. But if you were to have a problem that looks like this, where you have an addition problem here, and you have a multiplication happening outside of parentheses, what you can do is take this 3 that's multiplied against everything, and instead multiply it by everything on the inside. So 3 times n plus 3 times 5. Now, first of all, why do we need to do this? Well, you might be tasked with simplifying this expression, 3 times n plus 5. And note, first of all, you can't add n and 5. It's just equal to n plus 5 because we don't know what n is. Another note is that because we have parentheses here, parentheses are at the top of the hierarchy for order of operations, meaning what is inside parentheses must be done first. So in this case, addition is now higher priority than multiplication, even though it occurs lower than multiplication does in the hierarchy of priority there. We do addition first because it's inside the parentheses. So we can't just say it's like 3, if you didn't have parentheses here, this would be 3 times n plus 5, which is just equal to 3n plus 5. And note that here, that's going to be a different expression than what we ultimately get. Parentheses say, hey, do the addition first, but we can't. And this is what distribution allows us to do. It allows us to simplify this expression by distributing it in, and we can get ultimately 3 plus 15, 3n plus 15. Now, why is this simpler? Well, first of all, you might notice the parentheses are gone. But additionally, what this would afford us to do is to be able to combine like terms or do other things after the fact of distribution, which would further allow us to simplify an expression. For instance, if we were to have your expression be all of this plus 6, then once you distribute, you'll have that plus 6 left over, you'll have the plus 6 left over, and then you can say this is equal to 3n plus 21. And then if you consider this expression versus this one here, hopefully you recognize the latter is more simplified. There's less stuff going on, and importantly, there's no parentheses or anything. You can just read this off and use normal order of operations, 3 times n, and then plus 21. Right, so that's the most basic case of the distributive property. Let's go ahead and see a few more. So if I were to have a longer problem, well, you would do it the same way. You distribute the 3 to every part of this expression. So you have 3 times 2x, which is just 6x, 3 times y, which is just 3y, and then 3 times 6, which is 18. And this would be your new expression. Other notes, you could have a variable sitting in front. Maybe I'll make that x plus 1. Well, the way you do this is you do it the exact same way. Maybe I'll make this 2 so you can see what this would be. Well, you'd have a times x plus a times 2. And if you want to write this a different way, sometimes we write it ax plus 2a, pulling the number in front like we sometimes do. And so we have a times x plus 2 times a. That term a is now multiplied against each part in the initial expression, which was just x plus 2. Other things you could see x times x plus y plus 2, something like this. Well, let me circle this and move it over a little bit. This guy is equal to, well, multiply x by each term. X times x plus x times y plus x times 2. X times x is x squared. This is just x times y, and this is 2 times x, which I'll write as 2x instead. And so ultimately, what you're doing is you're taking x and you multiply it by each thing that's being added to or subtracted to within the problem. If this was instead, let me erase some stuff. If this was instead x plus xy, make that x times y right there already. And this would be me expand some space here. X times y. And then, of course, x times x is x squared times y. You can see that you're still going to have the same result. You might just compact it a little bit, but ultimately, you still have an extra x in each part. Right. And then, of course, lastly, what I'll say is you can have 2 times a variable. Now, maybe you'll do this like y plus 2. And you distribute the same way. You take all of this and you package it, you throw it to each term. So here you'd have 2x times y plus 2x times 2. This is just 2xy. This is 2 times 2, which is 4x. So you simplify it there. So procedurally, this is what you're doing. If you see some things multiplied in front of a parentheses, you take that thing and you multiply it against each part, and then you add at the very end. And note, the things you multiply to aren't each thing that's involved. Like you don't multiply the x and the y separately here, but each term, each thing that is being added or subtracted. And xy here in the middle example that I'm kind of highlighting right here, this itself is one term. You multiply all of that by x, or the thing that you'll be multiplying in. The thing on the outside gets multiplied by each term as a whole, and the terms are added or subtracted. Right, so this is part 1. I'll pick up next in part 2.